You believe you understand motion. You believe you understand why objects move and why they stop. You are wrong. Not partially wrong, not slightly confused. You have accepted a fiction so completely that you never questioned it. And that fiction has blinded you to one of the most disturbing truths in all of natural philosophy. I am Isaac Newton. I spent decades wrestling with the nature of movement itself. And what I discovered was not merely a description of how things behave. It was a revelation that shattered 2,000 years of human assumption. It should shatter yours as well. But first, I must show you the prison of thought you have been living inside. A prison built by Aristotle. A prison maintained by common sense. A prison you never knew existed because its walls look exactly like obvious truth. Let me ask you something. Something so simple it will seem absurd. Why does a ball rolling across a table eventually stop? Think about your answer. Really think. Because I promise you, whatever answer just formed in your mind is almost certainly the same answer humanity gave for over 2,000 years. And that answer is completely, devastatingly wrong. You said it ran out of force, did you not? You imagined the ball was given some quantity of push, some amount of motion, and it gradually used that up until nothing remained. The ball stopped because it had nothing left to spend. This seems obvious. This seems self-evident. This is precisely what Aristotle taught in the 4th century before Christ. And this is the lie that imprisoned human understanding for millennia. The ball does not run out of anything. The ball is being actively stopped. There is a difference between those two statements so vast that understanding it properly will reorganize everything you believe about the physical world. I need you to feel the weight of what I am about to explain. This is not trivia. This is not a curious fact for party conversation. This is the foundation beneath every machine ever built, every rocket ever launched, every understanding of motion in the universe. And it begins with a question that should have been obvious, a question that should have kept philosophers awake for centuries, a question that, astonishingly, almost no one thought to ask. If motion requires continuous force, as Aristotle claimed, then what force keeps an arrow moving after it leaves the bow? Think about this. The bowstring provides force while in contact with the arrow. The moment the arrow leaves the string, that force is gone. According to Aristotle, the arrow should immediately drop, instantly. The very instant contact ends, there is no force, therefore there should be no motion. But arrows fly. They fly magnificently. They travel enormous distances without any hand pushing them. What is happening? Aristotle had an answer. It was ingenious and completely wrong. He proposed that as the arrow moves forward, it pushes the air in front of it aside. This air rushes around to fill the space behind the arrow. And in rushing to fill that space, the air pushes the arrow forward. The medium itself provides the force. Motion creates the conditions for its own continuation. Beautiful reasoning. Absolute nonsense. Here is why it is nonsense. I discovered this through thought experiments that anyone could have performed. Anyone who bothered to actually think rather than accept. Imagine an arrow shot in a chamber from which all air has been removed. A vacuum. According to Aristotle, with no air to rush around and push the arrow, it should stop immediately upon leaving the bow. But this seemed absurd even to natural philosophers of the medieval period. They knew something was wrong with Aristotle's explanation. They could feel its inadequacy, but they could not escape its fundamental assumption. That assumption was the prison. That assumption was the invisible wall. The assumption was this: motion requires a mover. For anything to be in motion, something must be actively causing that motion at every moment. Take away the cause, and motion vanishes. This seems so obvious that questioning it felt like questioning whether the sun rises. But obvious things are often precisely the things we should question most aggressively. Obvious things are where the deepest errors hide. I questioned it, and what I found changed everything. Let me take you through the avalanche of understanding that follows from asking the right question. Because this is how scientific discovery works. One correct question leads to an observation. That observation leads to another question. That question leads to a principle. And that principle unlocks dozens of phenomena that previously seemed unrelated. This is the avalanche. Watch it build. Consider a stone sliding across a frozen pond. It travels far, much farther than the same stone kicked across a dirt road. Why? If motion requires continuous force, what force propels the stone across the ice? The ice is not pushing it. There is no bowstring, no hand, no obvious mover. Aristotle's followers would say the air behind the stone pushes it forward. But then why does it travel so much farther on ice than on dirt? The air is the same air. The stone is the same stone. The only difference is what lies beneath. Now slide a stone across polished marble. It travels farther still. Polish that marble with oil. The stone travels even farther. Do you see the pattern? Do you see what is actually happening? As you reduce something between the stone and the surface, the stone travels greater distances. What are you reducing? Friction, resistance, opposition to the motion. This is the key. This is the insight that cracked open 2,000 years of error. The stone is not being pushed forward by some mysterious force. The stone is being pushed backward by friction, by the resistance of the surface against its motion. Remove that resistance, and the stone travels farther. Reduce the resistance further, and the stone travels farther still. The motion is not being sustained by a force. The motion is being destroyed by a force. The role of force is not what you assumed. Let me say that again, because it is the most important sentence I have ever written. Force does not cause motion. Force causes change in motion. There is a difference between those statements that most people never grasp. Motion itself, once begun, requires nothing to sustain it. Absolutely nothing. Motion is the natural state. It is the default condition. It is what happens when nothing interferes. Force enters only when motion changes, when it speeds up, when it slows down, when it changes direction. Force is not the fuel of movement. Force is the sculptor of movement. It shapes and alters and redirects. But the movement itself exists, independent of force entirely. This is my first law. This is what I gave to humanity in 1687. An object at rest remains at rest. An object in motion remains in motion, unless acted upon by an external force. These words have been repeated so often that they have become meaningless sounds. You memorized them. You recited them. You never understood them, because if you truly understood them, they would terrify you. They should terrify you, because they describe a universe where motion is immortal, where velocity, once given, never dies of its own accord, where a ball thrown in the void between stars would travel forever, literally forever, for billions upon billions of years, until the end of time itself, unless something stopped it. Not because it has infinite fuel, not because it carries unlimited force, simply because there is nothing to make it stop. Stopping requires force, continuing does not. This inverts everything you intuitively believe. Let me make this concrete. You are in a carriage. The carriage is moving at a steady pace. You throw a ball straight up into the air inside the carriage. Where does the ball land? In your hand, exactly where it left. But think about what this means. While that ball was in the air, the carriage continued moving forward. If the ball had no forward motion of its own, it should have been left behind. The carriage should have moved out from under it. The ball should have landed somewhere behind you. But it does not. It lands in your hand. Why? Because the ball carries forward motion, the same forward motion as you, the same forward motion as the carriage. When you threw it upward, you only added upward motion. You did not take away the forward motion it already possessed. That forward motion continued unchanged throughout the ball's flight. It continued because nothing acted to stop it. The ball moved forward with the carriage not because some force pushed it forward while airborne, but because its forward motion simply persisted. It persisted because motion persists. Motion persists because motion is the natural state. This should disturb you. Most people accept it without feeling its strangeness. That acceptance is intellectual cowardice. Feel the strangeness. An object can carry motion the way a jar carries water. Motion is a quantity that can be possessed, that remains constant unless something adds to it or takes from it. This is not how you intuitively think about movement. You think of motion as an activity, as something being done, as a verb requiring continuous effort. But motion is not a verb. Motion is a property, a characteristic, a state of being that maintains itself indefinitely. Now apply this understanding to something you experience every day. You are riding in a carriage and the driver pulls hard on the reins. The horses stop, the carriage stops, and you are thrown forward, thrown violently toward the front of the carriage. Why? What force threw you? Nothing. No force threw you forward. That question itself contains the error. You were not thrown forward. You continued forward. You simply maintained the motion you already possessed, while the carriage acquired a new motion beneath you. The motion called stopping. The carriage experienced a force, the friction of the wheels, the resistance of the horses, the drag of the ground. That force changed the carriage's motion, but you experienced no such force. You were simply sitting there. And sitting there meant continuing forward at the speed you had been travelling. The carriage stopped beneath you. You did not stop, because nothing stopped you. Do you see it now? This is not wordplay. This is not semantic trickery. This is a fundamentally different understanding of what happened. In the common description, you were thrown forward. That description implies a force acting on you toward the front of the carriage, but there was no such force. In the correct description, the carriage was pulled backward relative to you. Or rather, the carriage was forced to stop, while you were not. The result looks the same. You end up against the front of the carriage, but the cause is entirely different. And causes matter. Understanding causes correctly is the entire purpose of natural philosophy. This principle governs everything. Everything. I cannot stress this enough. Once you truly grasp what I am telling you, you will see it everywhere. You will never experience motion the same way again. The avalanche of implication will bury your old understanding completely. Consider water in a cup placed on a table in a moving ship. The ship travels smoothly at constant speed. The water sits flat and still in the cup. Now the ship strikes a sandbar and stops suddenly. What happens to the water? It surges forward. It sloshes out of the cup toward the bow of the ship. Why? Was the water thrown forward? Did some force push it toward the bow? No. The water continued moving. The cup stopped. The water did what all objects do when unimpeded. It maintained its motion. The ship, the cup, the table, everything attached to the ship experienced the force of the sandbar's impact. That force stopped them. But the water was not attached. The water was sitting loosely in the cup, held only by gravity and the cup's walls. The water had no connection to the sandbar's force, so the water simply continued. It continued because continuing is what motion does. You must internalize this. Continuing is what motion does. Motion does not stop itself. Motion does not diminish on its own. Motion does not require renewal or replenishment. Motion simply is, until force makes it otherwise. Now let me show you how deep this rabbit hole goes. Let me show you how this single principle, properly understood, unlocks mystery after mystery. This is the avalanche accelerating. This is where understanding compounds upon understanding. Consider the earth itself. The earth is moving, not merely spinning on its axis, though it does that too. The earth is hurtling through space around the sun at a speed that should horrify you, approximately 67,000 miles per hour. Every hour, you travel 67,000 miles. You are moving at this speed right now as you listen to me speak. You are moving at this speed when you woke this morning. You have been moving at this speed your entire life. Why do you not feel it? This question plagued natural philosophers for centuries. If the earth truly moves, why does everything seem stationary? Drop a ball, and it falls straight down. If the earth were racing through space, should the ball not be left behind? Should it not fall at an angle as the earth moves out from under it? The fact that balls fall straight down was used as proof that the earth must be stationary, fixed, unmoving, the center of all creation. But we know the earth moves. The evidence is overwhelming. The mathematics irrefutable. So why does the ball fall straight down? Because the ball is already moving with the earth. Just as the ball in the carriage moves with the carriage. The ball possesses the earth's motion before you release it. When you let go, you only add the motion of falling. You do not take away the motion of traveling with the earth. That motion continues. It continues because motion continues. The ball falls toward the ground while simultaneously traveling 67,000 miles per hour around the sun. You travel that same 67,000 miles per hour. The ground travels that same 67,000 miles per hour. You are all moving together, so the relative motion between you appears to be zero. The ball appears to fall straight down because straight down is defined relative to you, and you share the ball's horizontal motion. This is why you do not feel the Earth's movement. You share that movement. Everything around you shares that movement. The air you breathe, the chair you sit in, the light entering your eyes, all of it moves together. And motion can only be detected relative to something that moves differently. In the absence of such difference, motion is invisible. Motion is unfelt. Motion might as well not exist, but it does exist. 67,000 miles per hour of it, every second of your life. This principle allowed me to destroy the Aristotelian universe entirely. Not merely correct it, destroy it. Because Aristotle's universe required the earth to be still, required it to be the fixed center around which everything else revolves. If motion required continuous force, then the earth's motion would require continuous force, and what could possibly push a planet? But if motion requires no force, only change in motion requires force, then the earth needs no push to continue orbiting. It simply continues. It continues because nothing stops it. The only force required is the force that curves its path. That prevents it from flying off in a straight line. That force exists It is gravity. But gravity does not push the earth forward. Gravity only bends the earth's path into a circle. The forward motion itself requires no explanation. The forward motion simply is. Do you see how the avalanche builds? One principle, one simple statement about the nature of motion. And suddenly planetary orbits make sense. Suddenly, the moving Earth makes sense. Suddenly, the failure to feel movement makes sense. Each understanding enables the next. Each answer unlocks new questions that have answers of their own. This is how natural philosophy advances. Not through isolated facts, but through frameworks that connect everything. Let me push deeper. Let me show you something about force itself that you have never considered. When you push on a wall, what happens? The wall does not move. At least, no movement you can perceive. So you might conclude that force requires motion, that if nothing moves, no force exists. But this is wrong. Your push is a force. The wall's resistance is a force. Two forces exist even though nothing moves. They exist in balance, in opposition, cancelling each other precisely. The wall pushes back against your hand with exactly the force you apply to it. This is my third law. Every action has an equal and opposite reaction, but I am not yet ready to explore that fully. First, I must finish showing you what the first law truly means. Return to the hockey puck on ice. You strike it with a stick. It slides across the ice. It travels far, but eventually stops. Now you understand why it stops. Friction, the force of the ice acting backward against the puck's forward motion. That force changes the puck's motion, changes it from moving to not moving. The puck does not run out of anything. The puck is stopped by something. But here is what most people miss. The puck is being stopped the entire time it travels. From the very first instant after your stick leaves it, the puck is experiencing a force opposing its motion. That force is small because ice has little friction, but it is there, constantly, relentlessly, acting backward against forward motion. The puck slows down the entire time it travels, not just at the end, the entire time. If you could eliminate friction entirely, the puck would never slow down. It would travel at constant speed until it hit the boards, or until it hit another player, or until something else applied force. But nothing in the puck's motion itself would make it stop. Nothing. The puck would travel a straight line at constant speed for eternity if no force ever touched it. This is inertia. The word comes from the Latin for idleness, for inactivity, for a tendency to do nothing. And that name captures something profound. Objects are lazy, not in a moral sense, in a physical sense. They refuse to change. They resist alteration of their state. If at rest, they insist on staying at rest. If in motion, they insist on maintaining that motion. Force is required to overcome this insistence. Force is required to make anything change. This resistance to change is not a minor property. It is perhaps the most fundamental property matter possesses, more fundamental than colour, more fundamental than shape, more fundamental than weight, because inertia exists even in the void of space where weight vanishes. Inertia is tied to mass itself. The more mass an object has, the more it resists change. The harder it is to start moving, the harder it is to stop. Consider two balls, one made of lead, one made of wood. Same size, same shape, very different masses. Push each with the same force. The wooden ball accelerates quickly. The lead ball accelerates slowly. Why? Both experience the same push, but the lead has more mass, more inertia, more resistance to change. It refuses alteration more stubbornly than the wood. Now push a ship, a massive vessel of timber, and iron. Push with all your strength. Nothing happens. The ship does not care about your push. Not because your push is not a force. It is. But because the ship's inertia is so enormous that your force produces almost no change. You would need to push for hours to produce any perceptible motion. Or you would need a much larger force. Sails catching wind, oars pulling water. These produce the force necessary to overcome the ship's immense resistance to change. This is why mass matters. Mass is resistance to change. Mass is inertia quantified. The more massive an object, the more force required to alter its motion by any given amount. This relationship is precise, mathematical. It became my second law, which I will address shortly. But for now, understand that mass and inertia are inseparable. They are two names for the same underlying reality. Think about what this means for the falling ball we discussed earlier. The ball falls because gravity pulls it downward. Gravity is a force. Forces change motion. The ball's motion changes from stationary to falling at increasing speed. The ball accelerates, but this acceleration is resisted by the ball's mass, by its inertia. The ball does not want to accelerate. The ball wants to maintain its state. Gravity forces it to change anyway, but the ball pushes back against that change. Not actively, not consciously, simply by being massive, by being matter. This is perhaps the strangest aspect of inertia. It feels like objects have will, like they prefer certain states, like they stubbornly cling to whatever they are doing. Of course, they do not truly have will. They do not prefer anything. But the mathematics behave as if they do. The physics behaves as if every object in the universe jealously guards its current motion and must be forced, against its resistance, to do anything else. Let me now bring this understanding back to your daily experience, because I do not want you to think this is abstract philosophy with no bearing on your life. This principle governs every moment of your existence. You are standing still. Your body is at rest. To begin walking, you must apply force. Where does that force come from? Your muscles. Your legs push against the ground. But here is the critical point. You do not simply push yourself forward. You push the ground backward. And the ground pushes you forward. Equal and opposite forces. My third law. But right now, focus on your inertia. Your body resists the change from standing to walking. You must overcome that resistance with muscular force. The larger your body, the more force required. This is why moving a massive body is more tiring than moving a small one. More inertia to overcome. Once walking at constant speed, you no longer need to overcome inertia. You have achieved your desired motion. Now you only need to overcome friction and air resistance, the forces that would slow you down. Your muscular effort maintains your speed not by pushing you forward continuously, but by countering the forces that would stop you. If friction and air resistance vanished, you would need no effort at all to keep walking. You would glide forward at constant speed with no muscular exertion, like a stone on ice. To stop, you must again overcome inertia. Your body wants to keep moving. You must apply force to stop it. That force comes from friction between your feet and the ground. You push forward against the ground. The ground pushes backward against you. That backward push decelerates you, slows you down, eventually stops you. Without that friction, you could not stop. You would slide forward forever, like that hockey puck. This is why walking on ice is difficult, not just because you might fall, but because the reduced friction reduces your ability to change your motion. You cannot accelerate quickly because your feet slip. You cannot stop quickly because your feet slip. Your muscular force cannot properly couple with the ground to overcome your inertia. The ice defeats your control over your own motion. Every vehicle you have ever been in operates on these principles. Every horse-drawn carriage, every ship, every cart. Force causes change. Motion resists change. These two facts together explain everything about how things move. Now I will show you how this principle extends far beyond sliding stones and falling balls. I will show you how it governs the heavens themselves, how it explains phenomena that seem miraculous for thousands of years, how one simple truth about motion unlocks the architecture of the cosmos. The avalanche continues. Watch it bury everything you thought you knew. Consider the moon, that pale disk crossing your night sky. It moves. Obviously, it moves. Every night it appears in a slightly different position against the stars. It circles the Earth approximately once every 27 days. But here is the question that should immediately strike you. Why does it circle? What force keeps it moving in that great arc? Before my work, the answer would have been something mystical. Celestial spheres, divine will, the natural motion of heavenly bodies. These were not explanations. They were admissions of ignorance dressed in impressive language. They said nothing about mechanism, nothing about cause. They simply named the mystery and declared it solved. I solved it differently. I solved it with the very principle I have been explaining to you. The moon moves in a circle because two things are happening simultaneously. The moon possesses motion, forward motion, motion that carries it through space in a straight line. That motion requires no explanation. That motion simply exists. It persists because motion persists. Left alone, the moon would fly off into the void, travelling in a straight line forever. But the moon is not left alone. The Earth pulls it. Gravity reaches across 240,000 miles of empty space and tugs the moon toward the Earth. This tug is constant, relentless. It never stops. Every instant, the Earth is pulling the moon closer. Every instant, gravity applies force. Now think about what happens when these two facts combine. The moon has forward motion. It wants to travel in a straight line, but gravity constantly bends that line toward Earth, not by stopping the forward motion, not by replacing it with different motion, by adding to it, by curving it. The moon falls toward the Earth constantly, but its forward motion carries it past the Earth constantly. The result is a curve, an endless fall that never reaches the ground because the ground keeps curving away. The moon is falling around the Earth, not toward it. This should astonish you. The moon is falling. Right now, it has been falling for billions of years. It will continue falling for billions more. Falling is not what you thought it was. Falling is not plummeting downward until you hit something. Falling is moving under the influence of gravity. The direction of that movement depends on what other motion you possess. Drop a stone and it has no sideways motion. It falls straight down. Throw a stone sideways and it has horizontal motion. It falls in a curve. Throw it sideways fast enough and the curve of its fall matches the curve of the Earth. It falls around the planet. It becomes a moon. This is orbit. Nothing more, nothing less. Continuous fall that misses its target forever. Every satellite circling every planet operates on this principle. Every planet circling every star. Every star circling every galaxy's center. Falling, endlessly falling, never hitting. Because their forward motion carries them past whatever they fall toward. And that forward motion, it requires no explanation, no continuous push. no divine maintenance. It simply persists. It persists because inertia preserves motion eternally, unless force changes it. Gravity provides force, yes, but gravity only changes the direction of the motion. Gravity does not create the forward speed. That speed was always there. It has been there since the formation of these bodies billions of years ago. It will be there until something finally interferes. Do you see how the universe opens up once you understand inertia? Do you see how this single principle makes celestial mechanics comprehensible? Without inertia, you need angels pushing planets. You need crystal spheres carrying stars. You need constant intervention to maintain constant motion. With inertia, you need nothing. Motion maintains itself. Physics becomes simple, beautifully, terrifyingly simple. Let me return to Earth and show you more immediate applications, because I know how easily the mind dismisses cosmic principles as irrelevant to daily life. They are not irrelevant. They govern your every moment. You simply fail to notice. You are in a carriage once more, moving at a steady pace. Inside the carriage, you toss a ball from one hand to the other. The ball travels sideways through the air and lands in your other hand. Simple, ordinary. But think about what actually happened. From your perspective inside the carriage, the ball moved sideways, a few feet at most. From the perspective of someone standing beside the road watching, the ball travelled a much more complex path. It moved sideways, yes, but it also moved forward. Carried by the motion of the carriage, the ball traced a diagonal line through space relative to the ground, even though it traced a simple sideways line relative to you. Both perspectives are correct. The ball really did move sideways relative to the carriage. The ball really did move diagonally relative to the ground. Motion is relative. It depends on what you measure against. This is not contradiction. This is simply how motion works. But here is what inertia guarantees. The forward motion of the ball relative to the ground required no additional force from you. When you tossed the ball sideways, you gave it sideways motion. Only sideways motion. The forward motion it already possessed simply continued, unchanged, undiminished. That forward motion was invisible to you because you shared it, but it was real. It was present. It was part of the ball's total motion, whether you noticed it or not. This has profound implications. It means that motion can be added to motion. It means that velocities combine. It means that an object can possess multiple motions simultaneously, and each motion persists independently until something specifically changes it. The ball had forward motion from the carriage. You added sideways motion with your toss. Both existed. Both persisted. The ball moved diagonally through absolute space while moving sideways through your moving reference frame. This is the relativity of motion, not the relativity of that German fellow who came later. Simpler relativity, more fundamental. The recognition that motion only has meaning relative to something else, that there is no absolute state of rest against which all motion can be measured, that you can claim to be stationary while hurtling through space at unimaginable speed, and both claims are equally valid depending on what you measure against. The Earth provides an illuminating example. You stand on its surface and feel stationary, completely at rest. But relative to the Sun, you are moving at 67,000 miles per hour. Relative to the center of the galaxy, you are moving at nearly 500,000 miles per hour. Relative to certain distant galaxies, you may be moving at millions of miles per hour. Which is your true speed? None. All. The question has no meaningful answer. You possess different velocities relative to different objects, and no velocity is more true than any other. But inertia does not care about relative motion. Inertia cares about change in motion, and change is absolute. When a force acts upon you, your motion changes. That change is real regardless of what reference frame you use to describe it. You may disagree with another observer about how fast you were traveling before and after, but you will agree that the change occurred. You will agree on the magnitude of that change. You will agree that force was involved. This is why force causes change and not motion itself. Motion is relative. Change is absolute. Physics must be built on absolutes. Inertia is the principle that connects force to the absolute phenomenon of change, not to the relative phenomenon of motion. Now let me address something that confuses even those who think they understand my laws. Let me talk about what happens in the absence of all force. True absence. Complete removal of every influence. You cannot experience this on Earth. Friction is everywhere. Air resistance is everywhere. Gravity pulls you constantly downward. There is no moment in your earthly existence when no force acts upon you. Zero force is a theoretical construct, not a lived reality. But understanding what would happen with zero force is essential to understanding what actually happens with the forces you experience. With zero force, an object maintains its velocity perfectly. If it moves north at 10 miles per hour, it continues north at 10 miles per hour forever. If it moves up at 3 feet per second, it continues up at 3 feet per second forever. If it sits stationary, it remains stationary forever. The velocity simply freezes. Whatever it was becomes whatever it will always be. This means there is no difference between rest and uniform motion. None whatsoever. An object sitting still with no forces acting on it, and an object moving smoothly at constant speed with no forces acting on it are in exactly the same physical state. They experience nothing different. Their futures are equally predictable. Their situations are equally stable. Rest is not special. Rest is merely one particular velocity among infinite possibilities. The velocity called zero. This disturbed many of my contemporaries. They wanted rest to be special. They wanted the stationary state to be the natural condition toward which all things tend. It was not. Rest and motion were equivalent. Neither required force to maintain. Both required force to change. The universe did not prefer stillness over movement. The universe was indifferent. Now I must show you something subtle, something that many people miss entirely when learning these principles. Something about the nature of force itself. Force is not a thing. Force is an interaction. It is not a substance that can be contained or stored. It is a relationship between objects. When I push a wall, force exists at the boundary between my hand and the wall. It does not exist in my hand alone. It does not exist in the wall alone. It exists in the pushing, in the contact, in the interaction. This matters because people often speak of objects carrying force, the way we earlier said objects carry motion. But this is wrong. Objects carry motion. Objects do not carry force. The arrow flying through the air carries velocity. It does not carry the force that launched it. That force existed only during the moment of contact between bow and arrow. Once contact ended, the force ended. The arrow then possessed only its motion, nothing more. This confusion between force and motion plagued Aristotelian physics. They imagined that a force was somehow impressed into the projectile, that the bow gave the arrow a quantity of force that the arrow then spent as it travelled. But force cannot be given this way. Force requires contact or influence. Force exists only in the moment of application. What gets transferred to the arrow is motion, not force. And motion, unlike force, truly does persist. When you throw a ball, your hand applies force to the ball during the throwing motion. That force accelerates the ball, increases its velocity. The longer your hand stays in contact, the faster the ball goes. But the instant the ball leaves your hand, your force ends completely. Whatever velocity the ball has at that instant is now the ball's property. And that property persists. Not because your force persists, not because some residue of pushing remains in the ball, simply because motion persists. Period. This is why I emphasize the first law before the second. You must understand that motion needs no explanation before you can understand what force actually does. Force does not create motion. Force does not sustain motion. Force changes motion. Force is the agent of change. Change and only change. Let me now address the second law more directly, because it flows naturally from everything we have discussed. Force causes change in motion. But how much change? This depends on two things: the magnitude of the force and the mass of the object. Apply a small force to a small mass, and you get a large change. Apply the same small force to a large mass, and you get a small change. Apply a large force to a large mass, and you get a moderate change. The relationship is precise, mathematical. It became the foundation of all quantitative physics. The change in motion caused by a force is proportional to that force and inversely proportional to the mass of the object. Double the force, and you double the change. Double the mass, and you halve the change. This is the second law expressed in words rather than mathematics. But the mathematics is where its true power lies. Acceleration. That is the name for change in motion. Not change in position, change in velocity. The rate at which velocity increases or decreases. Force equals mass times acceleration. This simple equation governs every physical interaction in the universe. From the collision of atoms to the collision of galaxies, nothing escapes it. Nothing violates it. Nothing operates outside its jurisdiction. When you push a cart, your force causes acceleration. The cart speeds up. The amount it speeds up depends on how hard you push and how heavy the cart is. When the cart rolls over rough ground, friction applies force backward. That force causes negative acceleration, deceleration. The cart slows down. The amount it slows depends on how strong the friction is and how heavy the cart is. Force and mass. Mass and force. Always these two in relationship. Always determining the rate of change. Consider the implications for your carriage experience again. You are travelling at speed. The driver pulls the reins. The horses slow. The carriage decelerates. But you were not connected to the decelerating force. The reins pulled the horses. The horses slowed the carriage through their harness. The carriage slowed through friction with the wheels. But nothing slowed you except friction with the seat. And that friction is small, so small that while the carriage experiences large deceleration, you experience almost none. Your deceleration is nearly zero. The carriage's deceleration is large. You and the carriage now have different accelerations, which means you will now have different velocities, which means you will now have different positions. The carriage stops beneath you while you continue forward. Your body slides along the seat. Your body pitches toward the front, not because anything pushed you forward, but because different forces acted on you and the carriage. You experienced less force. You therefore experienced less deceleration. You therefore maintained more of your original motion. This is the complete explanation. Force, mass, and acceleration. Different forces on different objects produce different changes. You and the carriage are different objects. The force that stopped the carriage did not significantly stop you. So you did not significantly stop. Now apply this to something more violent. You are riding at high speed. The carriage strikes a wall. The carriage stops almost instantly. In a fraction of a second, the carriage's velocity goes from high to zero. That is enormous deceleration. Enormous force was required to produce that deceleration. The wall provided that force. To the carriage, you experience no such force. You are not connected to the wall. You are not connected to the carriage firmly enough to share its fate. So your velocity does not change. Or rather, it changes only as much as your connection to the carriage allows, which is not much. You continue forward at nearly your original speed while the carriage stops. Beneath you, you strike whatever is in front of you inside the carriage. Or you fly through the front of the carriage if it is open. Or you are thrown from the carriage entirely. You were not thrown. You continued. The language of being thrown is wrong. It suggests a force acting on you toward the front. No such force existed. You simply maintained the motion you already had. The carriage lost its motion. You did not. The difference in your states created the collision, created the injury, created the disaster. This understanding could save lives, does save lives. When people understand that sudden stops endanger passengers precisely because passengers do not share in the stopping force, they begin thinking about how to change that, how to connect passengers more firmly to vehicles, how to apply deceleration force to passengers more gradually, how to reduce the difference between what happens to the vehicle and what happens to the person inside. Think about a belt, a strap that holds you to the seat. What does it accomplish? When the carriage stops suddenly, the belt applies force to your body. Not all at once. The belt stretches slightly. It applies force over time, but it applies force. It applies the force necessary to decelerate you along with the carriage. It connects you to the stopping process. It makes you part of the carriage for purposes of deceleration. Instead of continuing forward at full speed while the carriage stops, you decelerate with the carriage. Not as rapidly as the carriage itself. The belt has some give, but close enough. Close enough to save you from flying forward. Close enough to distribute the deceleration force across your body rather than concentrating it at whatever point you eventually strike. This is physics applied to survival. This is my first and second laws used to protect human life. And none of it would be possible without understanding the true nature of motion and force. Without abandoning the Aristotelian fiction that motion needs explanation while rest is natural. Let me take you deeper still. Let me show you how inertia connects to something even more fundamental. Something about the nature of matter itself. Why do objects have mass? This question haunted me, still haunts me. I cannot answer it. I could describe mass. I could measure it. I could quantify its effects with precision that has never been surpassed. But I could not explain why matter resists acceleration. I could not explain why there is something rather than nothing. I could not explain why the universe is built this way rather than some other way. But I could show that mass and inertia are inseparable. That wherever you find matter, you find resistance to change. That this resistance is not a secondary property, not an accidental feature. It is essential. It is definitional. Matter is that which has mass. Mass is that which resists change. Inertia is the name we give to that resistance. These three concepts form a unity. Remove any one and the others collapse. This means inertia is not just a law of motion. It is a law of existence. Everything that exists physically, everything made of matter, everything that occupies space and persists through time, possesses inertia. There is no matter without resistance. There is no existence without stubbornness. The universe is built from stuff that refuses to change without compulsion. Consider light. Light has no mass. Does light have inertia? In my time, this question was incomprehensible. Light was something else entirely. A phenomenon without parallel in the mechanical world. But I suspected even then that light and matter were more connected than they appeared. I suspected that light would eventually be brought under the same laws that governed everything else. I was right, though the completion of that unification came long after my death. For now, understand that inertia is the universe's resistance to itself. Every particle fights change. Every atom guards its current state. Every object insists on continuing whatever it was doing. This is not metaphor. This is physics. This is the fundamental behavior of matter at every scale, from dust motes to stars. And this brings me to the deepest implication of all, the one I have been building toward since we began, the one that should truly shatter your understanding of reality. You think of yourself as acting in the world, as an agent of change, as a being that decides and moves and alters. And this is true. You do act, you do change things, but you also resist being acted upon. Every action you take originates from a body that possesses inertia. Every movement you make must first overcome that inertia. You are not exempt from physics. You are an instance of it. When you decide to move, you must force yourself. Literally force. Your muscles contract. They pull on your bones. They apply force to your mass. And your mass resists. It resists with the same stubbornness as every other object in the universe. You overcome that resistance because your muscles are strong enough. Because the force they generate exceeds the threshold needed to produce noticeable acceleration. But the resistance was there. The resistance is always there. When something acts upon you, your body resists. Not by choice. Automatically. Mechanically. The force applied to you produces less acceleration than it would in a smaller mass. Your body absorbs the blow partially through its own stubbornness, its own inertia. You are protected by the same principle that threatens you when carriages stop suddenly. Inertia is why you are stable, why you do not fly apart at the slightest breeze, why you can stand on a spinning planet hurtling through space without being torn to shreds by the motion. Your mass holds you together. Your resistance to change keeps you intact. Without inertia, existence would be impossible. Change would be instant and total. Anything that altered would alter completely. There would be no persistence, no continuity, no identity through time. This is what Aristotle never understood. He thought rest was natural and motion was change. The opposite is true. Both rest and motion are states. Change is what happens between states, and change requires force, not motion itself, not rest itself, only the transition between them, only the alteration. You are a body at rest relative to the earth. You are a body in motion relative to the sun. You are both simultaneously. Both are equally true. Neither requires explanation. Neither requires maintenance. You simply are in whatever state you currently possess until something changes you. I gave humanity 3 laws. The first tells you what happens without force. Motion persists. The second tells you what happens with force. Motion changes in proportion to force and inverse proportion to mass. The third tells you that forces come in pairs. Every action has an equal and opposite reaction. Together, these three statements explain everything that moves, everything that stops, everything that changes or refuses to change. They are the grammar of the physical world, the rules by which nature writes its sentences. But the first law is the foundation. The first law is where everything starts. Because until you understand that motion needs no explanation, you cannot understand anything else. Until you abandon the Aristotelian assumption that things tend toward rest, you cannot see the universe clearly. Until you accept that a body in motion stays in motion forever, unless interfered with, you will continue asking the wrong questions. Stop asking what keeps things moving. Start asking what makes them stop. Stop asking where the force came from that propels the arrow. Start asking where the force comes from that eventually halts it. Stop imagining that motion is activity. Start understanding that motion is state. The universe is not full of things striving to be still. The universe is full of things striving to continue, striving to persist, striving to maintain whatever they were doing at the last instant and whatever they will be doing at the next. Change is the intruder. Change requires explanation. Motion does not. I told you at the beginning that what I discovered would shatter your understanding. I told you that the prison of Aristotelian thought had invisible walls. I told you that obvious truths are where the deepest errors hide. Now you see. Now you understand. The obvious truth was that motion requires force. The deep error was identical to that obvious truth. They were the same statement. The thing everyone believed was the thing that was wrong. This is how paradigms change, not by adding new facts to old frameworks, by revealing that old frameworks were upside down from the beginning. The Aristotelian framework explained phenomena by inventing forces that did not exist. Mysterious pushes from air rushing behind arrows, celestial spheres carrying planets in their eternal rounds, tendencies toward natural places that existed only in imagination. My framework explains the same phenomena by recognizing that most of those forces were never needed. Motion explains itself. Only change needs explanation. The avalanche I promised has now buried your old understanding. Good. Let it lie buried. Build fresh comprehension on the foundation I have given you. See the world as it is, objects moving and continuing to move, objects still and continuing to be still, force as the agent of change, mass as the resistance to change, everything connected, everything governed by three simple laws that encode the behavior of the cosmos itself. You asked why objects resist movement. Now you know. They do not resist movement. They resist change. A moving object resists stopping just as fiercely as a still object resists starting. This symmetry is the heart of inertia. This symmetry is what Aristotle missed. This symmetry is what makes physics possible. Go now. Look at the world with new eyes. Watch a ball roll across the floor and see friction stealing its motion. Watch a leaf fall and see gravity changing its state. Watch a carriage stop and see passengers continuing forward. See force and mass and acceleration everywhere. See the first law operating in every shadow and corner of existence. See inertia as the universal property of matter. See motion as the natural state that requires no explanation. You understand now what I discovered. What took me years of thought to formulate. What overturned millennia of error. What made modern physics possible. What still governs every machine and every motion in your world today. Objects do not want to move or stop. Objects simply want to persist. They persist in whatever state they inhabit. They change only when compelled. They resist that compulsion with their very substance. This is inertia. This is my first law. This is the truth that was hiding in plain sight for 2,000 years, waiting for someone to see it. I was that someone. Now you see it too. Do not let it go. Do not slide back into easy Aristotelian assumptions. Do not let common sense blind you again to the uncommon truth. Motion continues. Change requires force. The universe is stranger than you imagined, and far more elegant. That is the lesson. That is what Newton discovered. That is what should, and now perhaps does, shatter your reality. Go and rebuild it. Stronger this time, on foundations that actually hold.